Hello and welcome to week 4 of the GatesAir Connect Virtual Events webinar series. Today's webinar, DAB Complete Solutions for Total Network Deployment, is presented to you by GatesAir own Ted Lantz, VP and GM of our radio product line. Before we begin the presentation, we're just going to take a quick 3-minute break to allow everyone who is registered a chance to join. So sit back, relax, and we'll see you in just a few minutes. Hello everyone and welcome back to the GatesAir Connect Virtual Events webinar series. This is Teresa Crippen, Global Events Manager for GatesAir. We really appreciate all of you connecting with us today during our webinar. In place of many canceled face-to-face events and trade shows, we have lots of interactive content for you to see over the next several weeks with our virtual event series. In today's webinar, DAB Complete Solutions for Total Network Deployment, we have the VP and GM of the GatesAir radio product line, Ted Lantz. He will examine the advances in compact, cost-effective DAB transmission solutions, ideal for deploying across diverse geographies. He'll also cover new compact gap fillers, multi-carrier systems, and higher power liquid-cooled options that arm broadcasters with a full array of solutions that can be tailored to specific network needs. We'll have a question and answer session at the end of the presentation, and we encourage you to type in any questions you have in the Q&A panel, and I'll send out a broadcast message here so you can see where to type those. So feel free to enter them as the questions pop into your head, and we'll answer them at the end of the session. Without further ado, let's start the webinar. Please welcome Mr. Ted Lantz. Ted?
Right, thank you, Teresa. So do we have my screen sharing now?
Yep, you're great.
Okay, very good. And it's the right screen.
The right screen. You're good to go.
Okay. All right. So we'll take a little bit of time for us tonight and for others their morning, afternoon to go over some DAB and some offerings that we have to help with that solution. To kind of start out, though, maybe we'll kind of do a little bit of review on DAB a little bit and its offerings and some of its advantages, and then what solutions we have to help the broadcaster and the networkers to deploy a DAB network. So kind of starting out on the DAB itself and why DAB, you know, in a lot of different regions and a lot of different areas throughout the world, the spectrum has become very populated with FM and AM signals. And so, you know, the looking for different ways to become more efficient and provide more spectrum within the system has been what people have looked for, and more cost-effective ways to deliver the content. DAB offers that. So DAB does offer many services onto a network, and ultimately, because of that, reduces the amount of energy consumption needed. One is it takes a lower power transmitter to end up providing a lot of different signals through one multiplex, rather than having individual transmitters and antennas at various sites throughout different locations to be able to have that coverage. So it's a very efficient in spectrum and power efficiencies, does provide very good audio quality. And then what comes along with it is additional data services that not always have been provided through other means. So it provides a broadcaster the means of being able to expand their brand portfolio. You do have various information that you can provide at the receiver with your brand recognition, pad data, so that you have additional data that goes with it, traffic information, as well as weather, different logos, different advertising. So a lot of things that come along with DAB that didn't used to always be with traditional services. So that's some of the reasons for looking at DAB and what to do with DAB. With its structure, it does allow multiple radio stations to transmit on the same frequency. Basically, that number can be smaller or very many, depending on how you allocate the bandwidth. And you know, we'll take a look at that here coming up. A lot of stations use the same transmitter, so they share the same transmitter, and so that's a way to do revenue sharing among. So everybody incurs a little bit of the cost instead of one transmitter per broadcaster. So it's many broadcasters or many content providers sharing in a network cost. And it does become a very effective way to deliver a lot of content besides just the programming content, as along with data and data services to help with that revenue. So with the structure, if we kind of take a look at a different type of network or an example of a network, in this particular example, we show 4 different networks, totaling 18 stations. So one network has 2 stations on it, taking a capacity of 128 kilobits, so each of them at 64 kilobits per second. The second network has 4 stations on it. Then the third with 3, and the final one with 9, dividing that and allocating that total bandwidth. So this one's putting 18 stations into a capacity of 1.15 kilobits per second, which is the maximum payload, or approximately a maximum payload for a service. And based upon how you change those bit rates, you can put more stations on or you can put fewer stations on. It really just depends on the quality of service that the broadcaster is looking for or the network is looking for. Each of the networks have their own allocated capacity, so nobody can access each other. So the ensemble is a part of their services. And then you can reconfigure those services independently also, without impacting the others. So a lot of flexibility. It offers a lot of functionality, and you can see how, again, with one transmitter or one service, we can put 18 stations on, compared to having, you know, in a traditional FM, you'd have 18 stations with 18 different antennas. This is just a kind of a way of looking at how this is how that happens, as far as being able to get that many services. Not only is the bandwidth wider because of the spectrum that it's in, but also you know, it uses the DAB plus audio encoding. The DAB plus is like 2.5 times approximately better than the traditional AAC that was provided initially when DAB. So it provides even more services, as well as better sampling. And it is an AAC plus, I think it's V4 actually, from a coding technologies, and allows for bit rate reduction with very high quality. And it does show how you can provide different methods and different bit rate reduction, and again, for being able to allocate into those different sub channels to be able to put the number of stations that you can on the air. Then to provide, again, a quality of service and to look at what you want to do and how you want to maximize those services is forward error correction. In that, again, it's a kind of determination. There's basically 4 different types, of just 4 different methods you can use. And the bit error rate basically it does also affect your payload. That's one reason for kind of showing this. But in addition, it does affect the signal strength or the receive level at the, not so much the strength as much as the ability to be able to decode the bits at the receive site itself, so that you have very good receiver sensitivity. And the different rates or the different coding rates dictate what kind of bandwidth and capacity that you have. And it shows in your 64 kilobit blocks or channels how much capacity you would have. And that's just another type of structure that you can use in being able to get, again, your quality service, as well as what you're wanting to do from a at the receiver, and having a very good decoding capability. So when we take that all the way through, then now we kind of have here a block diagram of what would be a typical type of network and how those all go together. In this particular case, we're showing an EDI, an IP network. ETI is also available through like a public E1, T1 type of a network. In this particular situation, you look at the left is where all the content is from the different providers. So you can have one-to-many studios, and they're using the public or the cloud from an IP standpoint to provide that data to send it to the service providers. At the service providers, there will be the head-end units that do all the audio encoding and the data encoding that gets multiplexed together. And then once that is multiplexed, it takes the EDI stream, which is an IP interconnect, out to the transmitter site, and where you will have a digital transmitter, a CODM transmitter. And that's what we'll kind of spend some time talking about, as well as at the end a little bit about how we can encapsulate that data to be able to give you a very reliable network connectivity from your multiplexer and your head-end units to the transmitter itself. So moving forward, we'll take a look at the transmitters that we offer that help to provide putting the network and putting the transmitter or putting the signal to the air itself. We offer a wide range of transmitters for this. We have a very big portfolio both in radio and TV. If we look at it from a DAB standpoint, we go from a very ultra compact 80-watt unit up to 45 kilowatts in liquid cooled. So in air starts at 80 watts. Then when you look at the medium power all the way up to high power. In the medium power, we have a 300 watt and 300, 450, and a 550 and 750 watt. And then as we go up and we start putting them in a rack, so it would be like a 36 RU rack, and they can go bigger. They start at 1.2 kilowatts and move up to 13 kilowatts. So a wide range of flexibility and power, more power really than what you would need, but does offer you a lot of flexibility, as well as then at those power levels as you go up, liquid cool becomes very economical in different situations depending on location, as well as output power. And so those start at 3.8 kilowatts and move up to very high in power, as I said earlier, in the 45. So those are the products that we'll take a look at. We'll start at the lower power solution in our ultra compact. They come in 3 different kind of flavors there, or different models. We have a 1 RU, which is the very compact 80, 150 watt unit. And then as you kind of move up, we go to the 2 RU, which is 300 watt and 450. And then 2 different models in the 3 RU, providing you 550 to 750 watts. All of them do have hot pluggable power supplies, as well as hot pluggable or removable PAs. And this shows you the front view. In this particular case, it's the 1 RU unit, the 80 and the 150 watt. So on the front, as you can kind of take a look at here, and you can see we offer different input slots. And in the case of DAB, we offer 2 different transport stream availabilities, the ability to do EDI and ETI. So you can have one configuration that might be 2 EDI and 2 ETI for redundancy, and then those provide you seamless switching from a redundant standpoint, as well as the other input slot. If this was any of these can be also configured as a gap filler or a transposer. So like in input slot number 1 there, it's really showing as if that was an RF input and we were rebroadcasting. So we were taking an off-air signal and then rebroadcasting it, whether it be on the same channel as a booster, or we can retransmit it as a transposer to a different frequency. So those are the available inputs. I don't remember if I mentioned it, but there also is ability to have 4 EDI slots for the inputs, like in the input slot number 2. And as we kind of move to the right, everything is configurable both from the touchscreen on the front panel, which is a touchscreen LCD, and it allows you to navigate and move through the setup of the system itself right from the front panel. And if you move over to the Ethernet control, you can have access to the web GUI and do all the access and do all the setup and control, as well as remote access through that connection. So that gives you the connection to the outside world, as well as can give you the web GUI to be able to do setups. And then you have a USB port where you can download and save configurations and be able to reload those in different sites. That's the front panel interface. And then as we kind of look at down below at the rear panel itself, it provides you, from a signaling standpoint, we provide you with all the different ins and outs for synchronization. So whether you want 10 meg in or out, it's configurable, as well as 1 pulse per second for synchronization of the system itself. And then you have GPS, and it's an option of what GPS option you would want. And then the power supply, your cooling fans, and you can see the cooling fans are very accessible and serviceable, as well as the PA. And then your SMAs for your RTAC or your pre-correction for your signal, so that you're within your mask, and the RF monitor out. And really those particular ins and outs and front panel access and control go throughout the whole line, whether it be the 2RU or the 3RU unit. Well, what do I got going? Okay, there we go. So as a summary on the units itself, they are all Doherty, so they are very high efficiency Doherty amplifiers, and they are broadband, so they cover the whole band of 140 to 170 to 240 as far as channels are concerned. Within that, there is no jumpers or banding within it. So it is across the whole band, very high efficiency, 46 and above % overall. You know, not that many years ago, getting 30 and 33% overall efficiency was very good when you're looking at Class B, AB amplification to be able to pass a digital signal. As we spoke, we provide EDI and ETI inputs, and those are the different options that you have for your signaling for the inputs itself, and then provide high MER across those bands that we were talking about. It's greater or equal than 33 dB, depending on power and frequency. Any other units can be also be configured with the input card to be a booster or for an SFN. And as we spoke, very high in redundancy and reliability. That's, you know, pretty much, I think, as people have seen through, it's a pretty common theme throughout, not just our radio and DAB transmitters, but also our TV, really from a whole company standpoint. We're always looking to make things smaller and more compact and provide higher efficiency and modularity from a standpoint of reliability and serviceability. This just shows a little bit of a closer look at what we were looking at earlier as far as the inputs and what you can have those selected as far as an RF input on the left side for a transposer or gap filler, and then your transport streams as far as EDI and ETI and your front panel access control. Taking a look at the inside of the units, kind of under the hood type of a view of the transmitters themselves. You can see in this, there's really no cables. Everything goes into a connector, so everything's very clean. Everything's very serviceable. You can see the power supply kind of middle to the right as it plugs into a connector on a PC board. So that shows it's very serviceable and hot pluggable. Same way with the PA in the middle of the system itself. The modulator board input card. So depending on what we need to have as far as and what you guys, what the broadcaster needs as far as a configuration, everything's an option that needs to be and is pluggable within the system. So, you know, it can be set up in one configuration, and if you need to upgrade later to something else, that can be added within the system itself. So you can see very clean design with a lot of serviceability. And this is just a PA assembly itself, easily removed within a few minutes. You take out 4 screws and then you can pop the whole PA assembly out. So that's the low power, the ultra compact up to the 750 watts. As we move to the 1 power, it goes up in power now. And that will take us up to higher power levels up into the 2 kilowatt, and then we can rack and stack those to go higher in power. As you can see, we provide them in 300 to 2 kilowatt units, up to 2 kilowatts, and then again very high MER with the 33 dB and the same interfaces that we were talking about before for your ins and outs and hot swappable power supplies. And it will be as these are come, when you kind of look at it like the 2 plus 1 RU and the 3 plus 1 RU. What that basically is really saying is that we have 1 RU is going to be the exciter itself or the modulator, and then in a 2 RU or a 3 RU, which we looked at earlier, you can get either 300 watts, and as you go up in power up to 1.2 kilowatts, it goes into a 3 RU unit. Then moving on from that, as we go up in power from there, we have a 3.5 RU unit, and it's just adding in more pallets to the unit itself to give you a 1.5 to 2 kilowatts. And then we take those and we move them over into rack units. And so as we add amplifiers into the rack itself, then we go up into the power. So like in the 2, 3, 4, 6 PA and 8 PA, that's around 18 kilowatts, or no, 15 kilowatts in an 8 PA system in a 36 RU rack. If you go higher in power, then we start to move into a 42. And we'll kind of look at that a little bit later, how they start to go up in rack and power and sizes. But that gives you a good overview of how we take the individual units, the standalone units, and then we can move them and integrate them into a rack and go higher in power. And they keep the same features as what we were talking about in the lower power. So this gives you a look at a 6 kilowatt unit, which is a 4 amplifier system. Up in the very top is the AC mains for the AC mains distribution. So your AC from the breaker box comes into it, and then from those, then there's individual breakers built within that, and everything is distributed out from there to the main controller, exciters, and the PAs themselves. And as we kind of go down, then you have a system controller that monitors the PAs and the system itself. If it's well, we'll look at it in a liquid cool, it's a little bit different, but it's kind of the same functionality. You see that LCD display, and it gives you all the monitoring characteristics, and it monitors the system itself as far as telling you if you have any failures or any issues, and monitors the whole system. Main and dual exciters, whether you can have a single exciter or dual drive, and then each amplifier, and then the very bottom unit is the loads itself, or the reject loads for the combined systems, combined amplifiers. This gives you a block diagram of the control and the signaling that is within the system itself, and this is again the 4 RU, or the 4 amplifier, the 6 kilowatt unit. So in the upper left, we have the system controller, and shows you the front. And as you move to the right, it shows the rear and the control. So the control going to the combiner, monitoring the combiner, and as well as the control is in green, as the green lines, and the control between each of the amplifiers. And then as we look towards the right, which kind of takes us towards the rear panel view and the RF control, then it shows you how we are taking 3 dB combiners between each of the PAs and combining those, and then combining them again to give you your final output, and then going through your directional coupler. And then in the very bottom itself is the loads for the balancing loads for the unit itself. In the middle, you kind of see a splitter. I don't know if you see them real well, but coming out of the exciters itself and the drives, and that signal is split to each of the 4 amplifiers. So that's the air-cooled solutions. Then we move to the liquid-cooled, and so whichever particular method and efficiency and operation is right for a particular operation, then that's what we provide. Again, it stays with the same thing with the high broadband, high efficiency broadband PAs, low power consumption on the pumps and the heat exchanger. We offer redundancy, which we'll take a look at. There is a reserve tank in the for the system itself for filling, as well as keeping a reserve. So if you have a leak, or you have some of the liquid that has leaked out, then we monitor that and we automatically refill the system, or can add to the system, probably is a better way to say that. So starting out in the lower part of a liquid cooled DAB transmitter is 2 PAs at 3.8 kilowatts. Each of them are 1900 watts. And then we move up, and in this particular example, as we were talking about earlier, you go into 8 PAs and you got 15 kilowatts. The other functionality you have within the liquid cooled is the ability to have redundant power supplies. So we can have 3 power supplies within the unit, keeping you at 100%, but you only need 2 to be able to get there. So you can lose a power supply and still be at full power. Should you have 2 fail, then you're at half power, 50% power. So it kind of stays with the same theme as we've been talking about from a point of redundancy and the different flexibility you have within the system itself. This just gives a closer up view of the dual pump system. So you can see in the lower part of the rack on the left, the dual pumps. The one pump is more towards the rear of it with the little red, and the other one is, of course, right at us, at the very staring us in the face, basically. So that is for the redundancy within for a system. And then on the right, it shows you the refilling system, and that will hold approximately 8 liters of your coolant. And then if it needs to, it monitors that from the flow, and it can, through the monitoring through the system, it can release or put more coolant within the system itself. The heat exchangers are in 2 fan speed control or in 4, depending on how big of a system it is. You know, as we go up to a bigger system, you'll need the 4 fans for being able to properly cool the liquid as you heat it up and move it through, and the heat exchanger cools that. They are 24-volt DC speed control fans, and then they are programmable for being able to go in reverse mode, or so that you can clean any dirt or debris they might get into the fins, into the coolant fins themselves, so they can push that debris out should you have that. This gives you a overview of the different power levels and kind of the system configuration itself. So starting at a single PA at 1900 watts, it takes 2. We have the dual pumps from a redundancy standpoint, and then your single heat exchanger with the 2 fans, and it would be in a 36 RU rack, and shows you your output connectors. In a 1900 watt, it'd be a 7/8 output, and then it moves up depending on power. And so when we get to the 9.5 kilowatt with 5 PAs, that's where we move to a 42 RU rack. And so you can see the various options. So there's a lot of versatility in what you'd be able to have from a system standpoint. I will say traditionally, from a DAB network, it's usually, you know, maybe in some of the bigger regions or the cap cities, you'll have a bigger transmitter to cover an area, and then you'll have smaller regional ones. So, you know, a lot of times, I'm not saying never, but a lot of times 5 kilowatts kind of tends to be more towards the higher side. I mean, you do, in some places you do see a few bigger, but generally 5 kilowatts is kind of the higher power that a network would look to deploy, and then you would have smaller ones throughout your regional networks. Then this particular unit is called a multi-carrier. It's kind of a unique unit for special applications or unique applications. And what it allows you to do in this particular one, it has a total power of 240 watts, and it allows to have 3 different signals, 3 signals within the ensemble to broadcast through the common amplifier. Same touchscreen Ethernet control and USB for backup. 3 ETI inputs in this particular case. And then if we kind of look at the screen and spectrum a little bit, you can see that you can have 3 DAB carriers. And those you can have 2, you can have 3, you can have them adjacent to one another, you can have them on each end. So it's very flexible. You know, you could have a 9A and a 9C, for example. So it's very flexible in its operation and configuration. We do provide the correction for that. And some of the applications that's been used for is, for example, being able to have coverage in a tunnel itself. There are 2 units available at this point, 240, and then there's a 130 watt unit also available. It does use a Doherty so that you have a high efficiency operation. As we said, we have multiple carriers with 3 channels for adjacent or non-adjacent adaptive. Your traditional, whether you want optional GPS or GLONASS receivers, hot pluggable power supplies, your ETI inputs, and your web interfaces. So that's the DAB product offerings as far as the transmit itself to get the signal on the air and through the system. Then what we have is various M+1 type of configurations, and within the M+1 we provide the gate switch for those, and within that we have a few different offerings for that. So we have the for the large units going up to 7+1, we have the 3 different series, the 2 series and the 3 series, the 2E and the 2U and the 3E or 3U. And then we have the 4000 series, which is a 4+1. We'll take a little more look at that. And then the 2000 series itself is for 1+1 and 2+1 configurations. So with the 2 and 3 series, this gives you an idea what they look like from the front as far as, and also from the rear panel itself. In the 2E, it is a 7+1. In it, you would use external. So the E is for the external switches, and it would use external switches to be able to control the switching of the RF within the system itself. And then depending on your power of or depending on switches, that's how you figure out the maximum power that you're controlling with that. In the 2U, those would be internal. So we have 2 different power levels available. In a 7+1, it uses it's able to handle up to 80 watts, and in 350 watts, and you can kind of see the output connectors on it. It's a 4+1. So that gives you an idea kind of and then you have your different logic and control within the systems themselves. And that gives you an idea what the 2 and 3 can do, both from internal and an external access or functionality. So that offers a lot of different varieties for the type of configuration you would be looking at. In the 4000 series, it is a 4+1 system. Again, as you go up in power in a 4+1, then you would use external switches. If you we have a couple of different 4+1s in the 80 and the 130 watt. So depending on what your power is, that provides the internal switches. And then in a 4+1, again, you have the 350 watts with internal switches. Then in the 2000 series provide the lower main alt or 1+1 type of systems. And it shows you, again, offers the same thing from an internal switches and the power for it with 350 and 130 at a 2+1. And then as you go up in power and outside of those, then we go to external switches. This in the 4000 series, what we provide is we also provide a front panel mimic screen or diagnostic screen that you can look at. And so it shows you as you start from the left and go towards the right, it shows you both your RF input if it was configured as a gap filler where you're taking an off-air signal or a transposer. but it shows you your signal flow. If there's no RF, then it would just be show you the signal for the transport signal itself, whether that be ETI or EDI. And then it moves that signal and it shows you to each of the 4 transmitters that are used in the system. And in those particular transmitters, we provide you a status of where you're at, whether it's whether you have an alarm or an error, whether it's in standby mode, which would be like the +1, or whether it's on the air, and then where it is on the air. So the signal flow coming out of that to the antenna itself. You do have the ability to manually and automatically control which transmitter is going to the load, and your manual and remote control of the system itself. So it is a nice visual representation of when you want to walk up to it of what is happening within the system itself. Here's a block diagram or a layout of that 4+1, where what we're showing here is both the control signaling as well as the RF within the system and that switching within that 4+1 4000 series switch. So if we start at the left with the bright red with the transport stream, we show that transmitter 3 has been taken offline, and now the +1 has been substituted for it. So the transmitter 3's inputs now are routed to the +1 reserve transmitter, and then from there we also are controlling the switches. And so as we go to the right and in yellow, we've now moved the +1 transmitter from being in reserve to the on air, substituting the transmitter 3 that has been taken out of service. The control is both IP and RS-485. So you do have redundancy in its control within the system, and that gives you kind of a, the highlighting kind of gives you a signal flow within the system itself. So those are the those are pretty much everything that we provide from a transmitter. And then as you go into M+1 configurations, the different type of gate switches that we use, that you can use for those in your configuration. And then the next part that we can provide from the transport mechanism is being able to give you a very reliable and robust method of taking your head-end unit EDI IP stream and getting it to your transmitter and providing that signal. And what we do is we use the IPCONNECT. And so the IPCONNECT is basically a gateway for encapsulating the EDI signal, the IP signal from the head-end units itself. And it provides a lot of different functionality for being able to do that reliably. And in the case of IPCONNECT, it provides you with dynamic stream splicing and hitless protection. And it has a couple mechanisms for doing that, both from network diversity as well as time diversity. And so we can configure those to have redundant paths, as you can see up in this particular case here, where you have a WAN 1 and a WAN 2. The IPCONNECT monitors and is able to send those, it will send the data across both those paths. If one becomes bursty, or you have a drop bit, or you have a drop packet, I should say, then it's monitoring that, and in its buffer, then it can recreate and rebuild that through the backup WAN connection itself. So lots of functionality, really from a transport standpoint. It's all based off our Intraplex products, which we've been doing this for years, and reliable transport is one thing that is very high, and we do a lot of within those. And so that is a good way for being able to move your IP packets from your head-end unit to the transmitter itself, and have a lot of functionality and redundancy within the backup and being able to reliably transport the stream itself. So I think that is it. That is the end. And I guess now we will, I think Teresa might have some announcements, and then if you have questions, we can answer any questions.
Thanks, Ted. Before we get into the Q&A portions, I do have a couple of announcements. Again, if you have any questions, please feel free to type those in the Q&A pane and we'll answer them as soon as we get them. Just remember that this recording is available on the same link that you used to sign on after the show. It'll also be available on GatesAir.com and on our YouTube channel. It probably won't be yet this evening, so maybe the next day or so. We'll also be adding this webinar to our educational video library, and that can be found at GatesAirUniversity.com. That is our online hub of lessons and webinars about broadcast engineering. And that's all of the announcements that I have. So on to the questions. We currently do not have anything in the queue for questions. So if you have any questions, feel free to submit those at this time. And if you hear silence, it's just we're just waiting.
And then if there isn't any questions, but if you have some questions later that come to mind or things that you think of as you later on, you can always email us. You can email me at ted.lantz@gatesair.com. That's ted.lantz, L-A-N-T-Z, at gatesair.com. So if you have any questions that come up later, you can feel free to do that.
Hey Ted, we do have one question. It says, do you have any details of the DAB Plus head end shown in the very last slide?
Do I have I don't have details. We can send you some details on the head end units themselves. Those are usually done through a few different manufacturers. We certainly could send you information on those, and that could provide you additional details of some of the advantages and differences between the different head end units.
Thank you. So Mark S, that if you want additional details, you can reach out to your RSM and we can get them to you that way, or you can reach out to Ted Lantz directly. And he can get that information to you as well. And again, you can reach him at ted.lantz@gatesair.com. Any other questions?
All right. Guess we did okay.
I think so. All right, well, I'll just once again wanted to thank everybody for taking your time out today to listen to our webinar. Also, feel free to check out the other recordings that we have at gatesair.com, also on our YouTube channel, and also GatesAirUniversity.com. Tomorrow, we actually have another webinar set from our very own Martin Horsford School. That webinar will be titled Reinventing the Transmitter Site, MAXIVA PMTX1 Outdoor Transmitter and Applications Review. And I was also told that there will be a little bit of bonus material with that presentation. So I'm not going to disclose what that is, but Martin promised to have some very interesting slides for us. So again, if you need more information about upcoming webinars and other information that we have available in our virtual series, please visit gatesair.com/v-events. If you have any future webinar topics or any other information that you'd like to have for course material on GatesAir University, please let us know at marketing@gatesair.com. So I think with that, I will say thank you again for everyone for attending this GatesAir virtual event. From all of us at GatesAir, stay safe, stay happy, and let's stay connected. Thanks, everybody.
Thank you.